And here is the actual physical board. And as you can see, I decided to use purple just to be different. This one also has the ground plane surrounding everything that's not connected to a trace. So it adds filters, ESD filtration, and also is grounding the mounting holes on here. There are 6 of them. This is the opposite side of the board. And we also have the interface board. Basically, this is it. This is the interface that's used for the different displays. So I have one for COM1 NAV1, another one for COM2 NAV2, and another one for ADF, another one for transponder, and then I'll be using these to connect to my switches, instrument controls, and so on. And the way it's designed is that these connectors, I'll do this way because it's a lot easier. Here's the input. These are all inputs from the main board, which I showed previously. So the inputs come in here, and these go to other boards, other interface boards. So that one ribbon, one set of ribbons, are all that's needed to go to the main board, and from there they tie to the additional boards. The 20-pin connector connects to a 12-pin, a 2-pin, and a 5-pin. The 12-pin here has the connections for all the displays, which comes from multiplexer 1, which ties to individual 7-segment displays, such as these. So we have these and so on. And so these two are the pin 29 and 28, which tie to the displays, or LCD. These are the actual selection for the input multiplexers, which are connected to the other side, actually. So the multiplexer itself connects to here. So the address to this multiplexer is controlled by this 5-pin connector. And these actually tie to the individual components, like the 7-segment displays, the dual encoders or single encoders, push buttons. And so this one board does pretty much everything needed. And if you look in the back, you can see that this is what it looks like. You have the 20-pin here, the 6-pin here, which is S0 through S3, and also has the power connections, the +5 and the ground. The power input from a transformer comes here, and these are the connections to the additional boards, which do not need the displays. So the switch boards don't need displays, therefore there's no multiplexer on board. And so basically this is what it looks like. So this main board connects to the bottom part of the interface board, and the other ones connect to the other board, and so on. As I climb up the mount, you'll see additional boards, and they all tie into each other. So it saves a lot of ribbons. It saves an awful lot of point-to-point wiring, and that was the main reason why I went to design my own PC boards. That was thanks to a video that I saw on YouTube that showed how to design your own PC boards using a free CAD program called CAD, as well as how to ship it to the manufacturer, so you can get 5 boards for a total of $2 US. So if you want to do prototyping, that's an ideal way of doing this.